What if the most important moments of 2026 don't happen on your screen, but silently above your head? No alerts, no replays, just a narrow window where the sky lines everything up and then moves on forever. In the next year, planets will skim the horizon by degrees, stars will blink out behind the moon, and a shadow will race across Europe that won't return in this form for decades. Miss the timing by minutes, stand a few kilometers off, or look the wrong direction, and the moment is gone. So here's the real question. When 2026 is over, will you remember it? Or will you wish you'd looked up?
You click for the biggest sky moments of 2026. This is your countdown. We start in January with small alignments most people miss, but every step takes us closer to a European total solar eclipse in August that could define the decade. If you want exact windows and where to stand for a clean horizon, keep watching. You'll get a printable calendar, coordinates for prime viewpoints, and camera settings guidance. Miss one window, and you may wait years. The clock is already running. How many of 2020 SIXS milestones will you actually catch? 3 minutes, 1 dawn, and your entire season locks in. That's how the year opens. January lays low on the horizon with a compact pre-sunrise alignment that rewards clean timing. You're working under a shallow ecliptic, so planets sit in the glow and climb slowly. The payoff is color. Twilight gradients change by the minute, and those tight separations pop only if you start focused on infinity and ride exposure from the edge of nautical into civil light without blowing the highlights. January gives you practice in restraint. Short lenses between 35 and 85 millimeters keep the scene honest while you frame the line of planets against buildings, trees, or a ridge you scouted the day before.
Millions of people witnessed history yesterday as a total solar eclipse plunged parts of North America into darkness for 4 minutes.
Oh wow, that is fabulous! Here we go, it is fully on, you can see it fully now.
Scenes of awe and wonder all along the eclipse's path of totality.
February repeats the theme near dusk instead of dawn, swapping cold blue air for warmer haze and adding a bright conjunction that looks simple on paper but shifts by a degree or two in appearance with altitude. March spreads things out just enough that a telephoto can isolate two bodies while the moon drifts in to anchor the composition. April and May step up with the first solid run of lunar occultations, including grazing paths where the limb scrapes a bright star and makes the light blink on and off along the crater rims. These moments disappear fast because elongation stays low. Planets close to the sun sit buried in glare, and a single cloud deck over the western horizon cancels the entire show.
Crowds on the beaches of Mexico's west coast were the first to experience the astrological phenomenon. If anything puts our place in the universe into perspective, this is it. And it's hard to find something 30 million people can agree on, as the moon passed in front of the sun, completely blocking its light.
Also, no two conjunctions look alike. Same pair, different altitude, different ecliptic tilt, different contrast. At 10 degrees above the horizon, you fight absorption, dispersion, and a brighter background. At 20 degrees, the colors flatten, but the shapes sharpen. Treat each one as a new problem, not a rerun. Here's the structure that controls everything. Elongation, the angle between a planet and the sun, sets the raw window. Bigger angle, deeper darkness. Then the local ecliptic tilt, how the sun's path meets your horizon, sets the climb rate. In winter at mid-latitudes, the morning ecliptic can rise shallowly, so the planets slide sideways and glow rather than shooting up into dark.
Over the next 2.5 hours, cities large and small were plunged into darkness.
It does make you feel a little bit small. You have these huge heavenly bodies moving through the sky. It does humble a person to think about the majesty of our planets.
And living life in the fast lane. These spectators captured it from the Indianapolis Motor Speedway.
Civil twilight ends when the sun is 6 degrees below the horizon. Nautical runs until 12 degrees. For tight pairings near glare, best contrast often lands during late nautical, minutes before civil fully washes the sky. That's when you nail focus and lock your exposure. Dialing your spot is math you can do in 5 minutes. Drop your latitude into an ephemeris app Pull the azimuth and altitude for the target at your chosen minute, and note the sun's altitude too. Now face the correct bearing on-site and map that altitude to a real feature. If the planet sits at 5 degrees and that warehouse roof peaks at 3, you must move. One thumb at arm's length spans roughly 2 degrees. Use it to check sight lines. Confirm with a compass. Then walk until the foreground clears by a degree or 2. Early in 2026, the moon covers several bright stars and offers razor-edge drama along the limb.
Those who viewed the cosmic event from the natural wonder of Niagara Falls, including this BBC team, had the weather to contend with.
We really wanted to see the total darkness. That was crazy to witness.
But a full day of cloudy skies didn't dampen the mood.
The crowd here is just jubilant and excited.
Grazing occultations near the edge of the shadow path create multiple contacts as mountains and valleys slice the light. That's where high frame rate video pays off. You get discrete events, not a blur, and a timing curve you can match to predictions later. Think of these months as live drills for August. Your tracking mount gets tuned on the moon. Your focus workflow gets muscle memory. Your timing down to the minute stops feeling rushed. Print the Jan-May calendar with azimuth targets and twilight times for your latitude. Pack 35 to 85 millimeters for alignments, 600 to 1,500 millimeters for occultations, and set a video profile that holds highlights at low altitudes.
The sun's corona and its flares will be studied by NASA. For this astronaut, though, the significance of the eclipse isn't rocket science.
And you can see just how dark it is.
Then a stroke of luck, a break in the clouds.
There it is! Wow, that is spectacular!
Add a neutral density or strong contrast plan for Haze, and keep a spare battery warm. You've dialed the timing. Next, we push into mid-year when the sky gets brighter, the targets get faster, and precision turns urgent. 2 months out, your margin for error collapses. Miss one rehearsal, and you gamble the eclipse. June and July move faster. The Milky Way rises brighter in late evenings, giving you short, clean windows before the moon cuts in. Evening conjunctions tighten to a few degrees with better altitude, so you can work longer focal lengths without drowning in glow. A second wave of lunar occultations sweeps in, perfect for testing the exact rig you plan to run in August. Treat these as live drills under real pressure. Hotter sensors, thicker air, and shorter darkness. Summer adds hidden traps. Humidity softens contrast and lifts the background. So histograms creep right, and you overexpose highlights without noticing. At higher latitudes, astronomical darkness shrinks or disappears. If you rely on deep night to calibrate, you run out of sky. Ground heat pushes thermal shimmer through long lenses, so focus hunts even if you think it's locked. Many observers chase sharpness at infinity and still land mushy frames. You avoid that by focusing on hard edges and checking every few minutes as the temperature drops and optics contract. Use a mid-June occultation as a stress test. Pull predicted contact times, then dry run the sequence the night before with the moon at a similar altitude. Program voice cues or short alarms. Last safe focus. First contact, midpoint, recheck exposure, exit. Bracket exposures in one-stop steps around your baseline, and add a fast burst mode for the exact moments the star hits the limb. For manual focus, throw edge enhancement on a mirrorless body, or use a Badenov mask with a bright star near the moon to set the plane, then tape the ring. If your rig supports it, rack focus slightly and record a brief sweep so you can pick the true peak in post. Seeing rules your sharpness more than your optics. Over early summer in Europe and North Africa, the jet stream often weakens and shifts poleward, which can bring steadier high-altitude air but leaves you at the mercy of ground layer turbulence. Read forecast maps that show wind at 250 millibars for jet strength and speed. Slow, straight flow hints at calmer upper air. Pair that with surface wind and temperature gradients at sunset. Inland sites downwind of large water bodies can settle after midnight, while immediate coasts may stay turbulent from onshore breezes. If the jet rips overhead or sea breeze looks strong, pivot inland by 30 to 80 kilometers and gain a calmer boundary layer. Calibrate your eclipse sequence now. Build an exposure ladder that steps from prominences to inner and outer corona, and include a short burst for Bailey's beads. Preload intervalometers with 2 programs, a rapid sequence for contacts and a slower bracket for totality. Keep ISO conservative for beads and prominences to save highlight detail. Then open up for coronal structure by 2 to 3 stops with longer shutter times. Practice switching programs without menu diving. Run a countdown script out loud while the moon stands in for the sun, so your fingers learn the order. Travel light and redundant. A tracking mount under 5 kilograms keeps you mobile. A dual body setup covers a wide field for context and a telephoto for detail. Rehearse a 3-minute polar alignment workflow with a phone-assisted method or a compact polar scope. Power matters in heat. Carry a high-capacity USB-C battery, a 12V option for the mount, and short cables to reduce voltage drop. Now pick your July scouts. Along the future path, look for regions that post lower afternoon cloud rates and stable access. High plateaus with open horizons, dry valleys with road pull-offs, and urban perimeters with clear western or eastern views. Visit 1 month ahead to confirm sight lines, parking, gates, and any sunrise or sunset blockers. Note the exact spot you'll stand and a backup within an hour's drive. Grab the mid-year readiness kit, a planner with Sight Scout prompts, exposure tables for the moon and bright planets, and a route template for fast weather pivots. Training ends here. Next is the main event, a European shadow that won't return in this configuration for decades. Totality isn't just darkness. The atmosphere flips into a measurable lab. Temperature drops, winds shift, sky brightness plunges, and the corona's layered structure appears with streamers that map magnetic fields and temperature gradients. Your sensors will see it if you plan. Lock your plan now. Choose a primary site and a backup within 300 kilometers. Print your exposure ladder. Rehearse 1 week before at the same altitude and azimuth window. Pack redundancy and commit to the sequence. Grab the 2026 calendar and coordinates. Tell us which window you're chasing. After this shadow moves on, the next chance won't match this geometry for a long time.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.